Hello, it's Dr. Hickman, and I wanted to come to you guys today, doing for week 6, to talk about, week 7, to talk about essential questions and understandings, and to help you guys out in terms of how to create these things, is that's part of what you need to do for this week, and then also as it move forward, talking about these things, moving forward to creating lesson plans, unit plans, so on and so forth. So I want to go ahead and get started. And we'll start with the 6 understandings that you guys had to cover during your reading this week. I'm not going to go over these in much detail, but there you see them. Explanation: are you able to describe and demonstrate your high level of knowledge about a particular topic that's beyond recall? Can you make linkages to other information and ideas? The second thing, interpretation. This is, can you build meaning based on translations from certain narratives, text, data, whatever, those types of things. So can you create meaning from those things? Then you have application. Can you use knowledge effectively in new situations and in diverse, realistic contexts? So can you use what you know in different areas, different contexts? Can you adjust it? Can you adapt it to demonstrate understanding? Then you have perspective, which is critical and insightful points of view. Can you see things from a dispassionate and disinterested perspective? This was very important to me when I taught world cultures. Next is empathy, the ability to get inside another person's feelings and worldview. Different from perspective because it deals with from things from an emotional position, whereas perspective is more analytical. And then lastly, self-knowledge. This is your ability to think about your own thinking, to be metacognitive, your self-awareness of your own knowledge and ignorance, your ability to be reflective. All of those things are very important when it comes to self-knowledge. Now I would like to go over essential questions and how it is that we can formulate those. So with essential questions, there are 7 characteristics of essential questions. Number 1, they are open-ended, so there's no right or wrong answer for them. Number 2, they are thought-provoking and intellectually engaging. So these are things that students cannot answer in one word or one sentence. And they're also going to be able to build off of one another and give you an opportunity to facilitate a discussion. Number 3, they elicit higher order thinking, which looks like analysis, breaking things down, inference, being able to make a judgment about something that's not stated explicitly. Evaluation is making a judgment about something with support. And then prediction is your ability to think ahead about something that might happen based on the information that you know. Essential questions also connect to important transferable ideas within and sometimes across disciplines. So these ideas can be something that's studied in 2nd grade and again in 5th and again in 8th. You get the picture. Number 5, they raise additional questions and want to make students look into the particular topic further. They require support and justification. In other words, somebody's opinion doesn't matter. When they answer the question, can they provide some evidence to support whatever it is that they're saying? And then lastly, they recur over time. They're enduring. These are lasting questions that students can answer even after school. So that goes beyond just what number 4 says, they're important, that occur within and sometimes across disciplines. These are things that students can think about even as they are outside of school. So I have now 3 different lesson plans that teachers came up with. So these were actual teachers who came up with these lesson plans. And I just want to go over them. These were lesson plans that needed improving. And so I wanted to show you what they started with. And then I wanted to show you with how it is that I improved them to better represent understandings and essential questions. So this lesson's an Algebra 3 class is on quadratic functions. The first one, understanding, and remember, these should be conceptual, identifying the nature of a quadratic function. It's not a concept. That's simply identifying. That's looking at something and saying that's what it is. There's no understanding involved with that. Number two, being able to sketch a graph of a quadratic function and again identify its vertex, axis of symmetry, and find its maximum minimum. Identifying something again is looking and pointing. There's no understanding about that. Do I could simply mimic what I saw in another one. Being able to sketch a graph of a function, one could argue is indeed application and a way to represent visual learning. It's a little slim. It's a thin representation, but I think maybe one could argue it. Number three, can you relate quadratic functions to real world problems and situations such as firework trajectory or bridge construction? That I would say is an understanding, because now you're talking about relating it to a real world application, fireworks trajectory, bridge construction. So now you're talking about thinking like an engineer. With the essential questions, how can income from a rock concert be maximized? It's not open-ended, it's not thought-provoking, it's not higher order thinking, you're not connecting anything, not raising any additional questions, there's no support or justification, and doesn't recur over time. I don't even know what the question's asking. I'm assuming this is something that was probably asked maybe at the beginning of the lesson to hook students in. So that would be kind of what you would say is a non-essential question. How does a quadratic function model a free fall ride? Maybe that's high order thinking. You might have to provide some support for it to explain your answer. But again, I think that's a thin connection there. How can you tell maximums versus minimums? Again, there's a right or wrong answer. You could answer that in one sentence. And how can you find the time it takes in an accelerating race car to reach the finish line? Again, that doesn't require a great deal of thought. It's not open-ended at all. There's a right answer to it. It's way too specific for it to connect with any other discipline. And once you answer it, you don't want to ask any other questions about it. So let's go and look at how I changed this particular lesson with some different understandings and essential questions. So what I came up with, number one, the concept of change. If you're talking about functions, you're talking about change. So the concept you'll see of change is here. It's fundamental to understanding functions and requires explanation. That is something that's broad. That is something that is that students would have to explain. And it's something that they could apply the concept of change to other things. Number two, the symbolic language of algebra is used to communicate and generalize patterns in mathematics, which can be represented graphically, numerically, symbolically, or verbally. Compare that to this one here that said being able to sketch a graph of a quadratic function, identify its vertex, axis of symmetry, and find its maximum minimum. Which one is more of a understanding? Which one are you going to get students to be able to explain and apply? And again, as we talk about application, this is Algebra 1, this is an Algebra 2 class. You can even talk about this in a 6th grade class as they're talking about algebraic concepts. Number three, algebraic and numeric procedures are interconnected and build on one another to produce a coherent whole. Now we're talking about things building on one another so students can explain exactly what's happening. And also what you learned in 2nd grade, you're applying to 5th grade, you're applying to 8th grade, all to produce the whole, which in this case would be a quadratic function. Now let's take a look at our essential questions. How can data be organized and represented to provide insight between relationships and quantities? Higher order thinking. Notice all of these start with the word how. How can change be described mathematically? That goes across disciplines. So you can talk about that in geometry. You can talk about that in algebra. You can talk about that in 5th grade math. How are patterns of change related to the behavior of functions? That's more specific, but students would have to think about that. How are relationships represented mathematically? Students, that's something that young people can ask outside of their time in school. And then how is math used to quantify, compare, represent, and model numbers? Again, that recurs over time. That's a question that students are going to ask throughout their time learning mathematics. Now I want to go to biology. So I know I have some science folks here. And this is a lesson that's on evolution. And you'll see here that they have 9 understandings. I'm not going to read over all 9 of these. There are a lot of them. But you see these here, these three all deal with the question. They start with how. That's more of a question than it is an understanding. We talk about number four, this number eight, excuse me, the four elements in the process of natural selection. I list those things. I do not have to explain them, interpret them, apply them, nothing. So there's no way that that's an understanding. Understand the observations that led Darwin to conclude that species evolve. I can write those on the board and the kids can copy them in their notebooks, and that's it. There's nothing to understand there. That's simply listing something. If we go to the essential questions, I want you to pay attention. Each of these questions: what is natural selection? What did Darwin suggest? Name two tempos of evolution. What? These are all lower order thinking. There's no thinking. This is simply recall. So there's no reason for students to think. None of these questions are open-ended. They have a right or wrong answer. There's no connection with anything, even outside of this unit. Once you say what natural selection is, what other question is there to ask? So this is very low level. These are not essential questions at all. These might be questions that you ask on an exit ticket as the students leave, but imagine what type of assessments this teacher is doing to determine whether or not the students know this. These are multiple choice questions. These are true and false statements. These are matching, and these are fill in the blanks. Don't do that, ladies and gentlemen. So let's take a look at how I improved upon them. Concepts. Biological evolution is supported by scientific evidence from many disciplines, including mathematics. Now we're talking cross-curricular. Now we're talking about across the content area. Life continues to evolve with a changing environment. Boy, that's a great concept now. We're talking about evolution, changing environment, the concept of life, change in the genetic makeup of a population. Change is evolution. Again, we're talking about the concept of change and what the population is. And we're talking about the concept of time. Now we're talking about the scientific method, which is something that's applicable across many different sciences. And then scientific study can impact politics, culture, and religion. We see that now with climate change. So evolution was the same thing. How many, almost 100 years ago with the Scopes monkey trial. Essential questions: how has life on Earth changed throughout time? Compare that to what is Darwin's natural selection. How do natural processes create and shapes life's unity and diversity? Again, compare that to name two tempos of evolution and explain each. Then the last one is science absolute truth. That's an interesting question that students can ponder throughout the rest of their life. Is science truth? Again, as we talk about climate change, you have a group of folks who say that it is the truth. And then you have a group of folks who say, no, that's not happening at all. So I want to real quickly go over, because I know we have some folks who are studying the performing arts and world languages, and I just want to show you guys what some of these things look like. So world languages, when you're asking essential questions, you want to look at motivation, learning processes, and communication. So these are the types of world essential questions that you can ask. Why learn a foreign language? How will learning a foreign language enhance my life? What are language patterns? How can I sound more like a native speaker? In what ways does language convey meaning? How do I keep a conversation going? And we're talking about essential questions in the performing arts. You can talk about the artistic and creative process, interpretation and critique, and the role of art in society. Why do people make art? To what extent does my artwork change me? How do we read and understand a work of art? Is one picture worth 1,000 words? What a great question. How does art shape and reflect culture? In what ways have technological changes influenced artistic expression? So these are all examples of essential questions in the performing arts. I know I had to move fast. I only got 15 minutes according to QuickTime. So let me know if you have any questions about this. Email me and I will talk to you guys soon.